arcade. We're just about to check out our reverse parentheses task. We've been doing a lot of smooth sailing, and we're just about ready to start exploring the waters. But before we get into this one, I do want to warn you, this is going to be a bit of a tough one. It's not going to be super easy or anything. So the last time we encountered one that was particularly tough was up here, this almost increasing sequence. This is kind of a noteworthy gatekeeper kind of challenge. I mean, it was pretty tough to move on from this one. If you remember, our first approach didn't work, it timed out, and so we had to sort of modify it. And we had this left iterator and this right iterator over here. And that's sort of the main thing I just want to remind you guys of before we move on, because we're maybe going to try a similar strategy for this next one. So remember that, iterating from the left, iterating from the right. We're going to try to apply that now to our current task, which is this one, reverse parentheses. So let's take a look at it. Let's see what it's asking.
You have a string S that consists of English letters, punctuation marks, whitespace characters, and brackets. It is guaranteed that the parentheses in S form a regular bracket sequence. Your task is to reverse the strings contained in each pair of matching parentheses, starting from the innermost pair. The result string should not contain any parentheses.
Okay, so one thing about this challenge that's a little bit bothersome, I guess, is the fact that they sort of just interchange between calling them brackets and calling them parentheses. So something to keep in mind is these things are parentheses, these things are brackets, and these things are braces, also known as curly brackets. I guess I could have just typed that stuff. So basically parentheses, brackets, and curlies. Okay, so keep that in mind. I mean, really what they should be saying here is parentheses, like for all of this stuff, because I'm pretty sure the tests are only going to include parentheses. I don't think we're going to have to actually worry about other styles of brackets or anything like that. So we're talking about parentheses here. Okay, so basically the idea is we're looking at something like this, and basically we want to take the stuff inside the parentheses and we want to flip it. So instead of this BC, we want to switch that to CB, and we want to get rid of the parentheses. So basically we just pop it in where it belongs in the string, and then we're done. So that's basically the idea here. And there could be some nesting also. So if we're looking at this one, we find that we've got parentheses here within a larger set of parentheses. So something to notice about that is we're going to flip them and then basically flip the inner part again. So when we flip this larger, reverse this larger part of it, now it's going to begin with P, it's going to end with B, and that's what we're finding for this over here. And then we've got this MNO, but keep in mind, we're going to reverse that first, so it's going to become ONM, and then we'll reverse the whole thing. So since this is getting reversed twice, it's actually going to look exactly the same at the end as how it started. So that's maybe worth keeping in mind. We're going to sort of use that knowledge as we go through our algorithm today. Okay, so I already mentioned that we're probably going to use sort of a left and right method here, that we're sort of going to have a left iterator that goes in from the left and then a right iterator that goes in from the right. So basically the idea behind that is I want the iterator to sort of search from the left until it encounters an open parenthesis, and then the one from the right should go left until it encounters a closed parenthesis. And then once that happens, we'll just make a replacement. We'll say, okay, so we're going to have this left part, and then we're going to have the reverse of this middle part, and then we're going to have this end part. And we're going to concatenate it all together. That's sort of the idea here. So the left part I'm talking about is basically as we're moving in from the left, we're just going to store every non-parenthesis character. And that's going to be our left part, and then from the right part, we're going to store every non-parenthesis character. Okay, so we can get started on that. But Before we do, I kind of want to talk about this idea of recursion because, like we said, we've got these nested parentheses here. So since we have parentheses within other parentheses, that means it's not going to be enough to just go from the left and then go from the right and then flip this large thing and then be done. We're going to have to then say, okay, but what about inside this thing? Do we have to worry about any brackets in there? Okay, so that's where things get a little more complicated. We could deal with that on the basis of loops. We could use a for loop or a while loop or something like that if we wanted to get it done. But I want to talk about recursion because it's a good tool. It's a good sort of strategy to be at least aware of. You don't have to use it if you don't want to. It has its advantages and disadvantages, but I just want you to be aware of it. So we're going to talk about recursion. The example that we'll use for now is factorial. So if you're not familiar with factorial, we'll just do a bit of a review here. So factorial basically means if we wanted, like, let's say 4 factorial, and this is the official mathematical symbol for factorial. I'm not just being super enthusiastic about the number 4 here. It actually means 4 factorial. What's factorial? Well, it basically means we'll take our 4, we'll multiply it by 1 less than 4, and 1 less than that, and 1 less than that, until we reach 1. So we've got 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is still 24. So the answer is 24. Okay, so factorial, it's a math operation, and something to notice about it is that it grows very fast. So like 1 factorial, well, that's 1. 2 factorial, well, that's just 2. 3 factorial, we're going to multiply this by 3, so it's going to be 6, and then we'll multiply that by 4, so that's where we got our 24. And this is kind of starting to show us how fast this thing is growing. If I multiply this by 5, I get 120. So, like, that's pretty fast. That's a really fast grower, actually. In fact, factorial, I think that might have been on our big O cheat sheet. Yeah, here it is. So notice how fast that thing's growing, the n factorial. That's like faster than anything else. That is nestled right in the horrible zone there. So we probably want to avoid things that have a time complexity of factorial. But in terms of what factorial is, well, it's a useful concept. It's something that comes up a lot in math and therefore programming. So we're going to make a factorial function, and we'll do it using recursion. So, I mean, we could do something like this. We could say function factorial, and it's just going to take n as a number. In fact, maybe I'll call that num, just to be totally clear about it. Okay, so factorial takes an input of num, and we want to let result be equal to, let's say, 1 first of all, and then we'll say for, let's say, let n equal to num, n is greater than 0, n minus minus, and we'll just say result times equals n. And then we'll return the result at the end of it. So then if we want to call this, let's just say return factorial of 4, and we should expect 24 from that. Okay, we're getting 24. So this is working the way we want. Just to give you a sense of how quickly it grows, let's try factorial of 9. And we find that that's already a pretty large number. Okay, so that's sort of a loop method for doing factorial. So instead, what I'm going to say is something like this. I'll say, well, if num is greater than 0, then we're going to return num times factorial at num minus 1. Okay, we'll look at that and how that's working in just a second, but let's say if it's not greater than 0, what do we want to return? Well, in that case, we'll return 1. Okay, so is this also going to work the way we want it to? Let's find out, and then if it does, we'll find out why it's working that way. 120, I think that's what we found before. Yep, there it is, our 120. Okay, so that's what we want, that's what we're looking for. Why did this work? Well, just to make it clear, let's just undo until we have our previous method. So that was our loop method, and then this was our recursive method. So something to note is there's a lot of similarities between the two. For the loop method, we're saying result starts at 1. Starting at 1, and then from there, we're multiplying it by num, and then we're de-incrementing n, so we're going to multiply the 1 by, for example, I guess we'll use 4 for now. So we're going to multiply 1 by 4, de-increment it to 3, multiply that result by 3, de-increment it to 2, multiply by the 2, de-increment to 1, multiply by 1, which technically we don't need to do, but it is technically greater than 0, so not going to make a difference if we multiply by 1. I guess we could change this to a 1 if we wanted to, and we wouldn't really lose any efficiency, but just for consistency, we might as well do this. So then finally it's going to say, okay, so result has been multiplied by 4 times 3 times 2 times 1, and that gave us 24, so we return 24. Now this other method here is basically saying, okay, you're calling this with a num that's 4. Okay, so num is 4. Is 4 greater than 0? Yeah, for sure. So then we're going to return num, which is 4, times factorial at num minus 1, which would be 3. So it's basically saying, okay, we're going to return 4 times whatever we get from factorial at 3. Factorial at 3 would run again. It would say, okay, now num is 3. Is 3 greater than 0? Yeah, so we're going to multiply this. Whatever the result we get here is 3 times whatever this thing is. So basically, just to sort of keep track here, just from our first thing, factorial at 4, so I'll just write it off to the side here, f at 4, basically what we know we're going to get from this is 4 times f at 3, f for factorial again. So basically the idea is that now it's multiplying, it's doing 4 times factorial at 4 minus 1, which is 3. There we go. Okay, but the thing is, f at 3 is going to be the same as, well, pretty similar to this. It's going to be 3 times f at 2. So this is the same as 4 times, and we'll replace f at 3 with 3 times f at 2. Okay, so this is 3 times f at 2. All right, well, what's f at 2? Is 2 greater than 0? Yeah, it is. Okay, so it's going to be 2 times factorial at 1. Okay, I guess I'll just skip over the words here. So we've got 4 times 3 times, what was f at 2? It was 2 times factorial at 1. Okay, so 2 times f at 1. And what's f at 1? Well, is 1 greater than 0? It is. So we'll do 1 times factorial at 0. So we'll have 4 times 3 times 2 times 1 times f at 0. And what is f at 0? So let's find out. If num is 0, then we'll say, well, is 0 greater than 0? No, it's not. So we're going to return 1. So basically this becomes 4 times 3 times 2 times 1 times 1. And I guess that extra 1 there sort of shows us why we don't need to check if it's greater than 0. We could get away with just saying it's greater than 1. But the main thing is that when we multiply all this, it's going to give us that 24 that we're looking for. So that's how recursion works. It's basically calling up a bunch of instances of the same function. Notice the function is calling itself, and that's what makes it recursive. Okay, so basically when we're dealing with the loop method here, we could get like a time limit exceeded if our loop was too big. You know, if we started out with a num that was like a million billion or something like that. But with the recursive method, basically it's going to keep putting more instances of the factorial function onto the call stack, and therefore we could actually run out of memory if this one was too big. So there are other risks associated with factorial functions. The other thing is, you know, let's say we forgot this, for example. Now this is going to be an infinite loop, and it's going to say, okay, wait for the loop, wait for the loop, wait for the loop. And then eventually it's just going to say, it exceeded the time limit, it took more than 4 seconds, so we said, forget this function. But this one, it could be more problematic. I mean, it could actually overload the memory. So that could be an issue. But the main thing is, I don't think that there's a huge computation time difference between these two ways of doing the function. Anyway, I just wanted to introduce you to these recursive functions. I mean, we could even clean this up a bit. We could make factorial a lot more neat. Well, first thing we saw is that it shouldn't work any differently if we make this num is greater than 1. There we go. We still have our 24. The other thing is we're returning this. In this case, we're returning this in this case. So we could actually just say something like return num is greater than 1. We'll use a ternary operator. And if it is greater than 1, we'll do num times factorial at num minus 1. And otherwise, we'll return 1. So basically, it doesn't need to be any more complicated than this. So that's kind of cool. In fact, we could even say something like let factorial be assign the value of a function that takes num to this thing. And then we've got kind of a one-line function here. So still working. That's factorial, and that's a great example of a recursive function. Okay, so we are going to use recursion today. How are we going to use recursion? Well, basically the idea is that we're going to do our left and right iterator. We're going to creep in from the left side. We're going to creep in from the right side. We're going to store all the characters that we encounter along the way, and then we're going to concatenate them with the reverse of this thing in the middle. Okay, so we're going to get a better picture of that, a better idea of what that's all about in just a sec. So let's get this started. We'll say L is going to start at 0. That's going to be our left iterator. R is going to start at, I guess, length -1. And I might as well just go ahead and make a constant for length, which is going to just be s.length. Okay, so no major surprises there. So we've got our left iterator, we've got our right iterator. Now we also want to keep track of the left part of the string as well as the right part of the string. And this is just going to be sort of storing the characters that we encounter up to the parenthesis. So we'll say while L is less than or equal to R, so we don't want to go too far. We don't want to get to a point where L overtakes R. At most, we want them to sort of meet each other, in which case that means there weren't any parentheses in that part. And also, we want it to keep moving until it encounters one of these things. Okay, so basically, S at L, while it's not this thing, while it's not an open parenthesis, keep it going. So first of all, we'll say we want to toss this on the left part, so whatever S at L is. Let's put that onto the left part. Let's add it on. And then also we'll increment L so that it keeps going. All right, so before we go any further, let's just see if that's going to return the left part actually. So we'll execute that. And yeah, in this case it's just A. In this case it's still just A. I mean, it seems like it's working the way we want it to be. It's going up to the parenthesis, not including it. So let's do the same thing for the right. We'll say, well, the right index is greater than or equal to the left index, and while S at R, while the string at the right index is not equal to this closing parenthesis. So while that's true, we're going to say right part plus equals S at R, and then R minus minus, because it's going in the opposite direction. Okay, so let's see if that's actually taking care of the right part the way we want it to, and we find out, no, not quite, because it's giving us ED instead of DE here, and it's because of the way I did this. I said right part plus equals S at R. In other words, I'm basically saying right part is going to be equal to right part plus S at R. But really what I want to be doing is putting it onto the left part of, I want to be adding the new character onto the left of this string called right part. So if I do it this way, now it should hopefully work. Okay, DE, that's what we're looking for, and then Q in that case. Great, so that's what we're looking for. All right, so we've got our left part, we've got our right part, and basically what we want to do is we want to do something like this. So like left part plus middle plus right part. And let me just put that in parentheses for now. So yeah, that's basically what we want. We want the A, we want this middle part, which will be CB, and then we want the DE at the end. So we're actually going to have to define what this middle part is, but for now, let's just keep it like that. So actually, let's make a new variable. I guess we can call it middle part. There we go. So we're going to say let middle part be assigned the value of, we'll do s.slice LR. And from there, let's just do a console.log, or actually, let's just do a return of middle part. I don't want to go any further until we've actually got this worked out. So middle part, it's including this one, because remember, slice includes the beginning index. It does not include the end index. So that's kind of important, and it means since we don't want the parenthesis in there, we're going to have to put a +1 on our slice here. Okay, so there we go, BC. That's great. All right, so what do we want to do next? Well, the middle part shouldn't actually be BC, it should be CB. So we kind of want to reverse it. So we'll say something like this. Middle part is assigned the value of middle part dot split dot reverse dot join. So that was the method we used in our palindrome thing, right? For our first palindrome challenge. So there we go. Basically, and just to explain this, we're splitting this into an array. We're then reversing that array, and then we're converting it back into a string. Okay, so now we are getting the CB that we're looking for, and we've got our left part, we've got our right part, we've got the middle part. So this should work, right? I mean, we don't have to return middle part anymore. We could just do this. Okay, so notice it passed the first one. That worked just fine. It had the left part, it pasted in the middle part there, which was the flipped CB that came from inside the parentheses here, and then it concatenated the right part onto the end. So far this is working the way we want it to. The problem is it's not iterating. We're not doing recursion yet, so that's why there's still parentheses in this one. So instead we'll do reverse parentheses of middle part. Reverse parentheses. I'm surprised it didn't do an autocomplete on that one. Did I spell that right? No, I didn't. So let's grab that and put it there. Okay, reverse parentheses, middle part. So let's see if that works. Okay. So that could be an issue. In fact, that is an issue, because remember when we were doing our recursion before, we found that we sort of had to put in like an if statement or some kind of ternary operator, something to check if, when we were doing factorials, we were trying to check, is n still greater than 1? Or is n still greater than 0? And if it wasn't, we were just going to return 1, and aside from that, if it was, then we were going to call the function again. So at some point we need to tell it to stop calling the function. So under what circumstance are we going to do that? Well, basically, if L and R have met each other, if they've encountered each other, then we don't really need this middle part business. So basically, we'll just say if R minus L is greater than 0, so like if there is some part in the middle here, if L and R haven't met yet, then under that circumstance, we'll do this stuff. Okay, great. And if that's not the case, if they have met, then in that case, we'll just return the left part, because if you think about it, the left part, like this, executes first, right? So it's going to go, if it can, like if it's not going to encounter the parenthesis, it'll go all the way to right, which is basically the end here, length minus 1. So the left part will contain the whole string if it doesn't have any parentheses. So we'll just return left part under that circumstance. Okay, so that's kind of our recursion here. This would be kind of like our base case. That's when we get to the smallest possible. And then this over here is just calling the function again as many times as it needs to. So when we run the test now, great. It actually is completing, but we're having an issue. We're having kind of a strange issue, actually. It's okay, so basically the P is fine, but aside from that, we're having some issues. So we've got the A at the start, we've got the Q at the end here. You know what? I'm going to do a console log here for middle part, just so we can see what it's actually producing as that middle part before it calls the function again, and we'll spell console the right way. Okay, so look at this. This is the middle part. It's calling the function with this now. And that's kind of weird, because now the left part is basically going to go up to there. Like it's not going to include this open parent. The problem is, notice when it flipped this middle part here around, when it flipped this around, it didn't care to flip the parentheses, so like it ended with a P, and then before that there was a close parent, and then an O, and then an N. So P, close parent, O, N. Really what we want is for this to become, for this close parent to become an open parenthesis. So that's the main issue with this. So we need to do some other process. It's not enough to just reverse the middle part. We also need to say, okay, when you're reversing it, if you find these things, if you find these open parentheses, replace it with a close parenthesis. So we could do something like like this. So we could say let new middle be assigned the value of an empty string, and then we'll do a loop. So we'll say for character of middle part, and let's just throw a little let on the character there to actually declare it properly and to limit its scope to this for loop. So for every character of middle part, basically what we're going to do is we'll say if character is this open parenthesis, then we'll say new middle is assigned the value of close parenthesis plus new middle, whatever it was. We'll say if character is this thing, then new middle is that, the open parenthesis plus new middle. I'm basically just trying to add the characters on one at a time. And then basically, if it's neither of those, so if character is not equal to open parenthesis and character is not equal to close parenthesis, then under that circumstance, we'll just say new middle is assigned the value of character plus new middle. Okay, so there we go. And now we'll use new middle instead of the old middle. So now it's reversing it. We're not using this little shortcut here anymore. We're going to console log our new middle, and we're going to call our new middle, and we'll see if that's going to work for us. Okay, so we'll run the tests at this point, and oh, look at that. Okay, so we're passing this now. It's working. It gave us this, so it's actually properly switching up the order of the parentheses or the direction of the parentheses, and then it successfully found this part in here. So the recursion is working. It works for something that doesn't require the recursion. It works for something that does and has these nested parentheses. This one also has nested parentheses. It didn't have any difficulties with that one. What about this? Still nested parentheses. This one didn't have parentheses. It still worked. So ultimately, this algorithm is working pretty good. I mean, I think I can delete these parts over here. This looks like it's kind of doing what we want it to do, except until we get to something like this. The problem here is that our parentheses don't have to be nested. They could just be like side by side like this. And we're encountering kind of an issue because check this out. I mean, basically okay, there's a term for this. What we're using right now is, we call it a greedy algorithm. We're calling it a greedy algorithm because basically it goes from the left until it encounters an open parenthesis. It goes from the right until it encounters a closed parenthesis. And so it's basically saying, well, in between that open parenthesis and closed parenthesis, we have all of this stuff over here. So notice that's what it's getting as its new middle here. It's just taking this, reversing it, and it's getting that. So the problem with that is now it's got a closed parenthesis, got an open parenthesis. It's being too greedy. It shouldn't do it this way. It should only be taking this and then also be taking this. So that's kind of a problem with our algorithm right now. I mean, basically the idea is that as we go from the left, well, how are we going to handle this? You know, maybe keep going to the left until we find a closing parenthesis and then do something with that. I mean, we could try that, but then I think we'd face some other issues when we get into the nested parentheses. So we're going to try something totally different instead. And I mean, this was pretty good. In fact, if I were to try to submit this, I'd find it's passing 10 out of 13 here. So it doesn't pass all the sample tests, but it passes like almost all the hidden tests here. I mean, there are really only 3 tests, but we can sort of guess what the issue is with that other hidden test. It's probably that it has some other non-nested, multiple parenthesis groups that are sort of on the same level. They're not within each other, they're just kind of next to each other. Not necessarily adjacent, but just, yeah, at the same level. Anyway, the point is, we're going to try something different here. We're going to try to simplify this a little bit, and the way we're going to do that is we're going to use regular expressions. So, what are regular expressions? Well, if I wanted to summarize it, I'd say regular expressions are kind of they are a programming language in and of themselves. They're kind of like a very small, very terse programming language, and they're not specific to JavaScript. We can use them in lots of different languages, and we'll generally use them when we're trying to look at things like patterns in strings. So when we're working with strings, when we're looking at patterns in strings, regular expressions are probably a good candidate. So I guess, how should we get started? Well, if you've been reading Eloquent JavaScript at all, you might have noticed that they have a whole chapter on regular expressions. And I would definitely recommend this. This is kind of where I first learned about them. And it's, regex, they're an easy thing to sort of be anxious or nervous about, especially when you first encounter them. I found that this is a pretty good explanation, and it also includes kind of a cheat sheet close to the end here where it just gives us kind of a list of all the main commands that we're going to be using for regular expressions. In JavaScript, there are two ways that we can sort of instantiate, declare a regular expression. I mean, these are basically the two ways, and we'll talk about those. But before we do, I want to just sort of dive in a little bit here with regular expressions and what they're all about. So this is a very, very useful tool. So this is regex101.com, regex101. I think there are other tools like this, but this is the one I like to use, and it's basically very useful for just testing out these regular expressions and seeing if they work actually the way we expect them to. So basically the idea is we're going to build a regular expression up here. We're going to use a test string down here to see how it's matching up and stuff like that. So we'll say, oh hey, I'm sorry, that was a mistake, but not really, just to get some extra characters in there. Okay, great. So that's our sample text. And what do we want to try to match in our regular expression? Well, let's try just the letter A. Okay, so we can make these as simple as we want. So right now, our regular expression is just the letter A. And it's matching all of these letter A's that it's finding. And if you notice, we've got this G thing here. That's a flag. It happens at the end. Notice it's like /A/G. So basically, that's a regex flag. If we didn't put that in there, that's the global flag. So it wouldn't match all of the A's here. It would just find the first one and say, okay, found it. We're done. But we kind of do want to have that global tag on right now, or global flag, I should say, so that it actually does match every one of them. Okay, so what if we try like an I, let's say? Okay, well that's kind of weird because it's matching this one over here, but it's not matching the I over here. And we do have the global flag set, so why is that? Well, it's considering these two different characters. So it's an I, capital I, or lowercase I. Those are considered different things. Now if we want, we could match either one. So we could say I or lowercase I. Okay, so when we put that pipe character in there, it's basically saying it's the first one or it's the second one. And look at that, the little tooltip here is telling us it's an alternative. It acts like the Boolean or. Okay, so it's saying capital I or lowercase I. All right, great, nice stuff. Okay, so from there, let's say, maybe I want to match all of the capital letters. So I'll say, all right, I want all the capital letters. Let's say capital A or capital B or C or D or E or F or G or H or I. And that's, I mean, it's matching the I anyway. We could go further if we want the O in there, but that's going to take some time, like that's quite a lot of these pipes here. And the point of regular expressions is we want to keep it nice and terse. We don't want to have to write a whole bunch of stuff here. So we're going to close that, and we're going to do something else. So when we use these square brackets, basically the way it's going to work is anything in here is going to be an option. So there we go. Now it's going to choose anything. It's going to match any one thing from this whole list of characters. Okay, great. So it's matching the I, it's matching the O. But again, I have to write a lot here if I want to get all the way to the T there. So instead, this makes it nice and easy. If we're inside one of these square brackets, we can just do A to Z. Nice. Capital A to capital Z. That'll match any capital letter. And notice over here it's kind of explaining what's going on. So it's saying, oh yeah, that the square bracket part, it's matching a single character in the list below. A to Z, well, basically anything in the range from A to Z. And it says index 65, index 90. That sounds a little familiar. Have we seen that 65 and 90 before? Yeah, we have in the ASCII table. So 65 is the ASCII code for A, and 90 is the ASCII code for Z. So it actually is using those, and we can sort of demonstrate that by doing something like this. So A to Z, capital A to lowercase z. So now it's covering anything between 65 and 122, and I'm using that as a way of saying basically match any letter. But notice there are these risks here, and this is kind of characteristic of regular expressions that sometimes they give you more than you bargain for. So I'm saying A to Z, and what I meant is capital A to capital A to capital Z, and then lowercase a to lowercase z. If we look at our ASCII table, there's stuff in between. We've got this 91, 92, 93, 94. So like all of these characters are in between. And that's why when we go back here, you'll notice it's actually matching these square brackets as well. So that's why I put those in there, just to sort of show this isn't going to do exactly what we want it to. But we just do something like this: capital A to capital Z, and then also lowercase a to lowercase z. Since it's still in the square brackets here, that means it's going to match anything from this or anything from this. So basically all the capital letters, all the lowercase letters, but none of these square brackets or other punctuation kinds of things. Okay, so that's kind of nice. And maybe also we want like numbers also, 0 to 9. You know, I can just pop some of those in there. Great. So now it's matching numbers as well. Okay, so that's pretty nice. What else? I mean, is there a more efficient way that we could do this? Well, as it turns out, yeah, there is. We could do something like this. So notice if we were to just put W, then it's just going to match lowercase w. So there's some key words, or I guess key characters, I should say, in regular expressions, and we'll use a backslash as an escape character to show that we're not talking about just regular lowercase w, we're talking about keyword lowercase w, which stands for word. It's going to match a word character. So word character, notice from the tooltip, it's exactly the same as what I had before. It matches any word character which is equal to lowercase a to lowercase z, or capital A to capital Z, or 0 to 9. So exactly what we had just a minute ago, except this is a lot more efficient. Okay, then we can also say, like, if we don't want it to be a word character, we'll do capital W. And some people look at that and think it stands for white space. It's not just white space. It's just anything that's not a word character. It's the exact opposite. There are other ways we could do that. I'm pretty sure we could do something like this. If we use these square brackets, but then we put a caret at the front, that means it's going to match anything but what we put in there. So basically anything but lowercase w, or anything but a word character. So that's the same as what we had before with backslash capital W. Okay, so this is all regular expression stuff. There are other things, you know, like we could say backslash D for digit, and it's just going to match 0 to 9. So we've got other built-ins. I mean, that's sort of what I was showing you on the Eloquent JavaScript page over here with the summary at the end. So we can see the word characters, digit character. Actually, there is one for white space character, and it's slash lowercase s. And there's a lot of the same kind of stuff we've been looking at here. So maybe we'll look at some other things here. So we'll say, first of all, let's change our input string, because I want something that's going to illustrate a slightly different point. So we'll say cats, cots, cuts, casts, and closets. Not just regular CTS there. Okay, so there we go. We've got something, and you'll notice all these words kind of have some things in common. So I could say, all right, match cats. All right, great. It's matching the word cats. It's having no issues with that. Okay, then maybe I wanted to say match something that has C and then A or O. Actually, let's use the square brackets. A, E, I, or A, E, I, O, U. There we go. So we've got basically any vowel character inside the list here. So it's going to be C, and then anything inside the list here, and then a T and an S. Okay, so it's matching these three. It's matching cats, it's matching cots, and it's matching cuts. But it's not matching casts or closets or CTS. Okay, so maybe we'll open it up to those and we'll say, well, if you've got anything inside, and we do have a kind of a wildcard character, something that's going to say, yeah, match anything. So we'll say dot. Okay, so match, we've got a C, then an anything, and then a T and an S. But notice it's still not actually matching these other two over here. So let's try, maybe if we had like 2 wildcards. Okay, so now it's matching this one over here. Or if we had 4 wildcards, now it's going to match this one over here. Okay. Another thing we could do is we could say we want to make these optional, right? So if we make the first one optional by putting a question mark after it, now it's saying, okay, so it could have that wild card, or maybe it doesn't. So it's going to match this one, and this one, but then also this one because it doesn't have the wild card. Could we put another one of those in there? Yeah. So maybe there's another optional one, or another, or another. So now it's actually matching all these things because we have options. But that's getting a little weird. I mean, this is a very strange way of wording this thing. So instead, we can say, well, if you've got one or more of these wildcard characters in between. But look at what's happening now. So there's a bit of an issue. If we take a look at this, it's basically saying, well, I'm looking for something that starts with C and ends with TS and then has one or more other characters in between. So it's basically saying, okay, well, here's a C at the start, and then here's a bunch of other stuff, and then that ends with a TS. So basically, it's being greedy, like we saw before. So this is another one of those greedy algorithms. This is a greedy regular expression. Now, if we don't want this to be greedy, because by default, regular expressions are greedy. Keep that in mind, and that can be kind of unexpected sometimes. So definitely, it's something we want to be aware of. So if we want to make this greedy, not greedy, sorry, it's already greedy. If we want to make it not greedy, we can put a question mark at the end. So now it's going to say, okay, I want to find something that starts with a C. I want to find something that ends with a TS, and it could have one or more other characters in between, but I want to find the smallest possible set of other characters instead of the largest. So now with the question mark there, it's non-greedy. Now that's not to be confused with this, which basically means optional, so you can have 1 or 0 of these things. And that's the thing about regular expressions, because it's so terse, because it's such an efficient programming language in terms of not having to use a lot of characters in order to actually get a lot of information across. Well, because of that, you can sort of easily get some things confused. So like the role of the question mark, it has many different roles and it's context dependent. So we've got to be careful about that. Now, if you want to avoid that altogether, we could set another global flag, or sorry, set another flag, and it's going to be the ungreedy flag. So now we've got this capital U at the end here, and it's basically saying, don't be greedy. Just by default, don't be greedy. Okay, so we could do that, but for now, let's do it this way, just to sort of get used to it. Now notice it's matching this, it's matching this, matching this, matching this, matching this, but it's not matching this one over here because it doesn't have a wildcard character at all. So the plus basically says if it has 1 or more. Now the asterisk is going to say if it has 0 or more. So if I replace this with an asterisk, now it does match this thing over here. Okay, so those are some basics of what this regular expression stuff is all about. We could try, let's see. Well, I guess there's one other thing that I want to talk about before we move on, which is capture groups. So if we use parentheses, regular parentheses, then we're going to capture what's inside. So basically the idea here is now that I have this capture group around the inner bit here, that's basically just saying, well, okay, this first one, it's going to match cats. So the regular expression itself is matching this whole string cats. But then in terms of what we're trying to capture here with this capture group, that's just going to be the A. And then for the next one, it's matching cots, but the capture group is O. This one is matching cuts, but the capture group is U. And the capture group can be larger than just one character. It could be as or lose, depending on what the case is. Or maybe it's just an empty string in this final case over here. Okay, so that's basically how a capture group is going to work. Now the reason I wanted to show you a capture group is because since parentheses have a certain meaning inside of regular expressions, sorry, this is what I meant to do. So since these have a certain meaning, these parentheses, I can't actually just use those if I want to actually match the parentheses over here. Notice this is matching the whole thing. And then it's got this capture group, which is basically just whatever's, well, it's just the whole thing, it's just, I want 0 or more wildcard characters, so it's just going to say, okay, you got it, that's the whole thing. And the capture group, yeah, also the whole thing, because it was all in parentheses. So I'm going to escape these parentheses, I'm going to say, no, I don't mean the capture group parentheses, I mean actual parentheses. So I'm going to put this backslash over here, and now it realizes, okay, so open parenthesis, and then some 0 more characters, and then close parenthesis at the end there. Okay, so basically that's just matching the stuff that's inside of the parentheses, which might seem a little familiar because that's what we're trying to do in this problem. So it would match basically this. In fact, let's get one of these in here. Let's say this is now going to be our new test string. Okay, so check that out. First of all, it's being greedy, right? So since it's being greedy, it's capturing the outside group. If we wanted it to be not greedy about this, then it would capture, okay, so that's bringing us to a whole nother issue. So it's basically saying, well, we've got an open parenthesis here, and we've got a closed parenthesis over here. So maybe we actually do want it to be greedy in this case. All right, so we'll do something like that. But keep in mind, we don't care about the parentheses themselves. We care about what's inside the parentheses. So that's the thing we actually want to capture. This is going to get a little confusing in terms of our notation, but we're using the escaped parentheses. Now we're going to use unescaped parentheses to actually capture what's inside. So notice what it's matching is the thing that includes the parentheses, but what it's actually going to capture is the stuff that does not include the parentheses, just the stuff that's on the inside. So that's really what we want. That's what we want to do stuff with. So this is what we're going to use. This is going to be our regular expression. And I know it looks super weird, so if you have any questions about it, definitely let me know. I know the pain of regular expressions. I know how difficult it can be to actually get used to these things. The number one thing I can recommend if you're having trouble with them is just practice. Come on to Regex 101 over here and just jam out with these things. Just try stuff. You'll learn a lot. I can guarantee you that. I mean, when I first started doing regular expressions, I was just testing them out in here in this environment, and I found that wasn't super illuminating because there's stuff going on behind the scenes, assumptions I was making that ended up being faulty, and it got me into some trouble. So basically, we want to avoid that. We're going to use regular expressions here. So let's say something like okay, hold on a sec. I want to use my regular expressions here in the JavaScript environment, but really what we've been talking about over here has been all just general regular expressions. None of this has really told us how we're going to integrate into the JavaScript environment. So we need to find a way to actually bring this into JavaScript, and that's where we're going to look at the Mozilla docs again. Something I always recommend. So this is basically telling us about regular expressions. It kind of gives us a definition of what they're all about. We've talked about that at this point. It's got some nice examples. So, I mean, this is a nice reference as well. Just like Eloquent JavaScript, this has some good examples and that kind of thing. But the main thing is that this is what we want to look at. So this is kind of how it ties into JavaScript itself. So these are the main methods that we can use for regular expressions. So notice there are two types. Okay, there's these first two, so exec and test, and those are regular expression methods. So we would do our regex dot test, and then we'll put some kind of string inside. And we do regex dot exec, and then put some stuff inside. Whereas all these other ones down below, like all of these, match, search, replace, split, these are all string methods. So instead, we'd have our string, and then we would do dot match, and then put the regular expression in there. Okay, so basically, which ones are we going to use? Well, I guess we'll do dot test. We'll do dot test first, and then What else? We'll probably use test, maybe we'll use match, maybe we'll use replace. Let's take a look at how some of these work. So we'll do test first of all. We'll say return this regular expression, and in fact, since that's a regular expression, we've got to do that. And we'll say dot test, and then just s, our string. So let's execute that, and it just says true. That's it, just true. It does match. It's saying, yeah, it's got him. And then I think there was one below somewhere that didn't have it, right? Wasn't there one? Yeah, where are the parentheses? It says false. I didn't find anything that had parentheses in this one. Okay, so this probably looks super weird, but that's a regular expression, and that's basically another way of saying, hey, does this thing have a set of parentheses? An open and closed parentheses with 0 or more things inside? And in this case, the answer is no, it doesn't have that. Whereas in all the other cases, it's saying, yeah, for sure, it's got more than one, in fact. Okay, so we're going to use that. We could also, let's see what exec does. Exec is a little weird, I'll be honest. I don't use it very often. So notice exec is giving us an array, and in that array we have the thing that it's matching, right? So this is the thing that the regular expression matches, the thing with parentheses on the outside. And then the capture group, it's giving us this as well. And if we didn't have the capture group, like if we didn't have the second set of parentheses in there, the actual parentheses, non-escaped, then it wouldn't give us the capture group because there's no capture group now. So it's a good thing to have that. I mean, there are other ways we could do it, right? Like we could just work with what we had as this first thing and then just say, okay, well, ignore the first character, ignore the last character. It's just a little easier to use this capture group thing here. Okay, so those are the two methods that we can use, test and exec. Those are going to be our regular expressions methods. But we could also do something like s.match and then put our regular expression in there. So I'll copy that, pop it in there, and we'll run that. And you'll notice that's giving us pretty much the exact same thing as what we had before. So whether we want to use exec on the regular expression, whether we want to use match over here. Now, the other thing about this is that I haven't put the G flag in there yet. So that was the global one. Remember, it was the thing that we had at the end there. So let's put that in now. We'll see how that changes things by having the G in there. Okay, so hasn't really changed it in this case. No, hasn't really changed it in that case. Is it going to change it in any of these cases? Well, let's see. Not that one. Ah, right. It's greedy. So let's try this, and we'll take a look at how that's going to affect test 6. Uh-oh. It doesn't like that. Okay, so it didn't like that flag. I don't know, maybe we'll do something like that. Just another way to say not greedy, and test 6. Okay, great. So now we're seeing that we're actually getting 2 matches out of that. That's what we were looking for. All right, so we'll probably do something like that for now. I'm just going to keep it greedy. And let's see what else we've got. So, okay, we could do replace. That was another method that we saw before. So replace is very useful. Let me actually, before we get into this, let's get that out of there, and we'll do a replace with something like, well, what do we have here? That was test 6. Okay, so this one has got a lot of E characters. Let's just say we want to replace the character E with an underscore. Yeah, let's try that. S.replace, and we're replacing the E with the underscore. Okay, so here's one. We replaced the E with the underscore. But test 5 was the main one I wanted to look at. Oh, well, there's still a bunch of E's here, though. Why didn't it replace them all? Well, by default, replace is only going to do one of them. So if we wanted to make this all of them, we could do a regular expression. We could say regular expression with the character E. So when you're using replace, we don't have to use just a character or a string here. We could use a regex. And we're still having the same issue, and the reason is because we need the global flag on that thing. So now that we have global, it's going to look for all of these, and it replaces them all. Okay, so that's a little nicer. That's a nice thing to do here. We could do other stuff too. Like we could say for replace, what we're finding is that the first argument, yeah, it can be just a string, maybe a single character, or it can be a regular expression, and maybe even a regular expression that sort of matches more than one thing, or that captures one thing. So maybe what we actually want to capture is whatever comes after the E. Okay, so that's going to be in our capture group. Now, if we run this, some slight differences. This one is no longer matching because it doesn't have something after it. It doesn't have any wildcards. So now we're seeing the E and the R are getting both replaced with this underscore because it's taking the next character as well. Okay, now the reason I wanted to show this off is because we have a capture group in here. So instead of this thing, instead of just replacing it with a single character, we can actually do a function in here. And this function is going to have two arguments. It's going to have the full match, and it's going to have the capture, the thing that it captured. And I'm just going to do a console log for now of the match and the capture, just so that we can see how the two compare. So the capture group really should just be that second thing. There we go. So, oh, yeah, that's the thing. We're not returning anything, so we actually do need to return the thing that we wanted to replace this thing with. Okay, and there we go. So first one, it's matching an E and then an R. The capture group was just the R because it's taking the thing after the E. Next, it was, this is hard to tell, but it's an E and a space, and it's matching the space. That's the capture group. Here it's capturing the end. So let's say we just wanted to replace it with this and then also put the capture group back in. Let's say we wanted to put that character back in instead of taking it out. So now it's going to look like it did before. So it's replacing the E with the underscore, but then whatever it had afterwards, it's keeping that there. It's keeping it the same. And maybe, we could even say it's going to double up whatever it finds. So it's going to have that E, but then also again. So anything that has anything that comes after an E is now getting doubled up. Okay, so that's basically a cool way that we can use replace. So we get a lot more mileage out of replace this way because we can replace more than one thing at a time. We can replace it in a more interesting way instead of just some other character. So we're going to use all this stuff. We're going to use replace, we're going to use probably test, and we're definitely going to use this regular expression. In fact, we could just pop that in right now. So we could say something like this. So replace this. We have the match and we have the capture. Basically what we want to do is we want to return the capture, but we want to flip it, right? So we could say capture dot split dot reverse dot join, just to reverse what we have in the capture group. And now look at that, it's actually passing the first test because it's taking this thing, it's flipping it around to, well, actually, sorry, it's taking this thing, it's capturing just what's inside, it's flipping it around so it's CB, and it's replacing it with what this whole thing was. So now it's that. Okay, but then now we're kind of having an issue here because it's not like it's not iterating inward or anything like that. So, okay, maybe that's not ideal. Because now that's the other thing. We're finding this thing, we flipped it around, but we're not flipping the parentheses. We're still kind of having the same issue as before. Now we could fix that issue by using something like what we had over here, like we could take this part, which was kind of our modified flipping algorithm, our modified reversing algorithm, so that when it reverses it, it also takes care to keep the parenthesized groups as still being parenthesized by reversing the parentheses. That's kind of complicated. Instead, I want to find a way that we can make this work from the inside out. So let's go back to the drawing board here. We actually do want to get this inside group over here. So maybe instead of doing a wildcard here, we'll say, okay, it can be almost anything, except what it can't be is this open parenthesis or this close parenthesis. Okay, so now basically this thing is saying match anything except for open parenthesis or close parenthesis. And keep in mind we had to escape those with the backslash. And now it's saying, okay, well, I can't match this group out here because this group has parentheses inside of it. So it doesn't actually correspond to this anymore. We have to go all the way in for this to work. So, okay, that's fine. We can do that. So now this is the regular expression that we want to use. So we'll go back in here and we'll replace this with our new regular expression. And you'll see what happens when we do that. Okay, so let's see. Is this better? Well, let's go up here. Okay, so this one still worked. This one didn't quite work, but it failed to work in a different way than before, which is good. It's actually better because now it's just taking this and it's replacing it with the reversed version of what's inside. So between the L and the P, now it's just going to have O-N-M. L, O-N-M, P, great, that's what we're looking for. But now we still have this this outer group here, so we're going to have to find a way to deal with that. And furthermore, if we go down to test 6 over here, we still, we didn't match all of them. We flipped this one, we didn't flip this one. Maybe we can handle that by just putting the G on the end there, just to make sure it's going to capture all of them in one pass. So let's see, does 6 work now? Actually, yeah, 6 is working. So we've made it one step closer to what we're looking for, so that's good. But we need to find a way to keep this iterating. We need to find a way to make sure that this will keep going until there's nothing left, until the resulting string, like this one here, contains no more parentheses. So luckily, we have a way of testing that, which is this right here, the test. So basically what our code is going to look like is while and I might as well just use this one over here. So I'll say, while you still have that thing, while this dot test s, let's do all this. Except I'm going to modify it a little bit because the idea now is that we don't want to be returning this because that would end the function. We're just going to say s is assign the value of s.replace, all that stuff. And then at the end, we'll say return s, and we'll see if that's going to work. So run the tests. A moment of suspense here. Oh, yeah, look at that. Check marks all around. Everyone is very happy with this. So this is good. This is very good. Okay, and maybe we could even do something like this just to be a little more efficient about it. We could say const, and then const is going to be, const re is going to be assigned the value of this, and re stands for regular expression, and we'll put it in there. We'll see if it still works. What we're finding is that it still works, and also we can put it in here and do an re.test there. Okay, so this is looking pretty good. We're using this one little regular expression here, and it's so powerful. Look at what it's doing for us. It's replacing all this stuff and also actually working, which is an advantage that this algorithm did not have. Okay, now one more thing I want to do here is this function. Look, it's a one-liner. It's taking these as an input. It's returning just this one thing. So I'm going to go ahead and make this an arrow function. We might as well. Living in the era of ES6, we might as well use it, right? So there we go. That should work, and it means we don't need this anymore. And there we go. So that is, let's see, still working? No, it's not working. Okay, why is that? What did I do wrong here? Match and capture, return capture, that's split. Okay, let me just shrink these down a little bit just to make it a bit easier to see. Okay, c.split.join, is it having trouble with that or something? Is something wrong there? Oh, okay. Well, what part of it was the issue? Was it the semicolon I put at the end? Yeah, it was the semicolon. Okay, let's put the semicolon at the end there. Great. So s, and by the way, just to demonstrate, so we're saying s is assigned the value of s.replace. Is replace a mutating function? Like, could we get away with just doing it this way, s.replace, and not assigning s the value of that replacement? Like, is this actually modifying s, or is it making a new string? No, it's making a new string. So that's why we do have to say s is assigned the value of s.replace, all this stuff. And I do want to sort of fill this out, match and capture, and then make this one capture. Okay, great. So that's nicer. That's let's see, still working. Still working. Very nice. Okay, so then what else could we do with this? Well, I guess we could do something like this. We could say const flip. And flip is just going to be this function right here. I mean, this is what flip is doing. It's flipping these things, right? So then I'll put flip in here. Okay, great. And let's just do this. Oh, come on. There we go. All right, so that's working good, I think. Could it be better? Well, I mean, as you guys know, I tend to like doing this. Just to go for another little one-liner there. And now, okay, it's passing all the visible tests. Is it going to pass the hidden tests as well? Let's try submitting it. Oh, yeah. Okay. So, that's great. We're at the end of the task, and we're at the end of the smooth sailing module. Look at this. Intro is 22% complete. We are really making some headway here, so this is good. This is good. All right, do we want to finish up with this one? Well, I guess I'll just make a comment. This didn't work. Sad face. Okay.